So we discussed the first trigonometric ratio of tangent, and remember that tangent is just a comparison or a ratio between the opposite side over the adjacent side in a right triangle. There are two more ratios that we're going to look at, and those are right here. One is the sine ratio, and the other is the cosine ratio. And once again, I'm going to refer back to this acronym that we talked about earlier, SOHCAHTOA. We talked about tangent being opposite over adjacent. Now we're going to talk about the S of sine and the C of cosine. And based off the letters, you might even be able to figure out what these ratios are going to be. But just in case, let's take a look at sine quickly here. The sine of theta, it gets abbreviated S-I-N. Please pronounce this sine. This is not sin. It will be a sin to call this sin. This is sine theta. We lop off the E for abbreviation purposes. Not sure why, but this is sine of theta. That ratio will always be opposite over hypotenuse. The opposite side over the hypotenuse. So if we make a sketch of a triangle, and once again I'll label it the 3, 4, 5 triangle, and once again I'll put theta as my missing angle down there. The sine of theta now is just the ratio of the opposite side over the hypotenuse. So if you want to label, here's opposite, here's adjacent, here's hypotenuse. Label your O, your A, and your H. The sine of theta is the opposite side, which is 3, over the hypotenuse, which is 5. 3 over 5 is the sine of theta. Okay? And when we refer to this acronym, sine is always opposite over hypotenuse, O over H. And you can probably guess what cosine, C, is going to be. And cosine of theta is equal to not opposite over hypotenuse. This one is going to be adjacent over hypotenuse. This is where the K of SOHCAHTOA comes from. Cosine is adjacent over hypotenuse. So if I draw this sketch one more time, curvy hypotenuse. Draw this one more time and put theta down here again. And I'm trying to figure out, well, what's the cosine of theta? Well, the cosine of theta now is the adjacent side over the hypotenuse. So 3 over 5, that was the sine, because that was opposite over hypotenuse. Cosine is adjacent over hypotenuse, which in this case would be 4 over 5. Okay? So, general recap, SOHCAHTOA is a acronym to remember sine, cosine, and tangent, and then the ratio. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So we'll practice that in a couple examples here, and then we will be all set. So you're looking for the sine of A, you're looking for the sine of B, you're looking for the cosine of A, and you're looking for the cosine of B. And now I would recommend just trying it yourself. There's the bell. Sorry, we're not done with class yet. I would recommend trying yourself, and then you can fast forward and see if you get it right. But sine of A, okay, so here's theta. I'll look at theta for angle A. From angle A, here's opposite, here's adjacent, and here's hypotenuse. So then since sine is opposite over hypotenuse, that would be 15 over 39. O over H is sine, and that can actually simplify. You can take a 3 out of each of these, and it simplifies into 5 over 13. Okay. I'm actually going to jump down to this one. Since A is still my reference angle for this one, I'm going to do the cosine of A. Cosine, remember, is adjacent over hypotenuse, A over H. So this time it's 36 over 39. And I can take a 3 out of each of these, and it simplifies into 12 over 13. Okay. So I'm going to do the same thing. I still have the sine ratio of opposite over hypotenuse, same ratio of adjacent over hypotenuse, but now my reference angle is angle B. So this is no longer my reference angle. This is my reference angle, which will change O and A. The hypotenuse will stay the same, but now from angle B, this is opposite and this is adjacent. Okay, so now for the sine of B, it's still opposite over hypotenuse, but now my opposite is this side, which is 36 over 39, which once again is 12 over 13. And then the cosine of B is adjacent over hypotenuse, 15 over 39, which simplifies into 5 over 13. Okay. And there's some more, there's actually theorems that support this, that the sine of one is the cosine of the other. But just be very careful that you're starting with the angle that you're looking for, so that you can label your opposite, your adjacent, and your hypotenuse sides correctly. All right, we'll do a couple more examples here. Number 2, find the values of x and y. Leave your answers to the nearest tenth. So, here's x, here's y. I can't use Pythagorean theorem yet because I only know 2 of the sides. Okay, but here's the angle that I know, right here. There's my theta, 35 degrees. So from 35 degrees, here's opposite, here's adjacent, and here's hypotenuse. So let's just try to solve for x first. If I was going to solve for x first, I'm solving for the opposite side. So I know whatever the ratios I need the letter O, because I'm solving for O. I'm solving for opposite. So if I'm solving for opposite, I need to know another thing. Well, I know my hypotenuse is 53. So I'm solving for opposite when I know the hypotenuse. So O and H. So I want the acronym, or I refer to the acronym. Which one uses O and H? Well, that's so katoa, so I know I need sine. So the sine of 35, the sine of my angle, is equal to opposite, which is x, over hypotenuse, which is 53. So you set up your trig ratio, you know that the sine of 35 has to be some number over 53. I need to go get my calculator again. So you put the sine of 35 in on your calculator and you get 0.574 is equal to x over 53. And now the final step to get rid of a divide by 53, you will multiply each side by 53. 0.574 times 53 gives you roughly 30 I guess this says round to the nearest tenth, so I will listen. It'll be a 30.4 for x. And then now we need to solve for y. Now keep in mind, y is the adjacent side. So now I'm going to use adjacent and hypotenuse, so I'm going to use... Yeah.
Are you busy?
Yeah, what's up?
I was just not here this morning for Arn's
Okay.
second hour, so I was wondering if you were able to teach.
Yeah, can you come back in 5 minutes?
Yes.
Okay. So now we're going to solve for y, which is the adjacent side. So to solve for y, since it's the adjacent side, I'm going to use cosine of 35 equal to y over 53, adjacent over hypotenuse. Okay. So you type cosine of 35 in on your calculator. The cosine of 35 is 0.819 equal to y over 53. Multiply each side by 53 again, rounded to the nearest tenth. Y is equal to 43.4. Excellent. So you want to make sure that you're using the right ratio here. We needed sine for x and we needed cosine for y. Okay. All right, we're going to do a couple more example problems here, and then we will be all set. I'm going to save number 3. I'm going to skip past number 3, and I'm actually going to do number 4 and number 5 just to wind this out here. Okay, so you're skiing down a hill with an altitude of 800 feet. The angle of depression is 15 degrees. Find the distance you ski down the hill to the nearest foot. So I'm just going to do a really rough sketch here. Okay, you're skiing down a hill. Altitude is 800 feet, so this distance is 800 feet in the air. The angle of depression, we'll say that this angle right here is 15 degrees. Find the distance you ski down the hill to the nearest foot. So what you're looking for is this one. Okay. So the tricky part about this is you have to figure out which trig function you're going to use. If you're going to use sine, cosine, or tangent. Now to answer that question, since this is the reference angle right here, I would label from here, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay. I don't know anything about the opposite side, and I'm not solving for it, so I do not want O. I know my adjacent side, I'm solving for the hypotenuse, so that's A and H, so toa, I need cosine. So the cosine of 15, the cosine of this angle is the adjacent side over the hypotenuse, 800 over x. On your calculator, you'll do the cosine of 15 and you get 0.966. It's equal to 800 over x. The quick way that you can do this is if you have, when the x is in the denominator like this, ultimately what's going to happen is these two are going to switch positions. So you can just do 800 divided by 0.966. And if you can remember that, you can go with that. But technically the algebra behind that is that you have to multiply x to each side. So then this becomes 0.966x equal to 800. Then now to get x by itself, you divide each side by 0.966. 0.966 divided by 0.966. So what you're doing is 800 divided by 0.966, which is what I referred to there. So if you want to do the algebra or if you remember the trick, it doesn't matter. And then either way, you should get an answer of 828. And it's to the nearest foot, so we're going to leave it as 828 feet. Okay. And one more example, and then we will be done. The angle of elevation of a ladder leaning up against a wall is 70 degrees. Okay, so you got a ladder leaning up against a wall. And I was going to try to make this 70 degrees, but it's certainly not 70 degrees, so not drawn to scale. So that's 70 degrees right there. We'll pretend. Here's the ladder. The base of the ladder is 1.4 meters from the base of the wall, so that's 1.4 right there. Find the length of the ladder to the nearest meter. So we're looking for the length of the ladder. Okay. So once again, here's my reference angle. This is the opposite side. This is the hypotenuse. This is the adjacent side right there. So I label O, A, and H to help me. And once again, since I know the adjacent side, I don't know the hypotenuse, I'm working with A and H. So once again, I am going to use cosine. So the cosine of my angle, the cosine of 70, is equal to 1.4 over x. You put the cosine of 70 in on your calculator and you get 0.342. These two are going to end up switching positions like I said earlier, so you're going to end up doing 1.4 divided by 0.342 and you get an answer to the nearest tenth of 4.1, and this is in meters. So after you sketch it out, I would think it's really important for you to remember or to figure out which of the trig functions you need to use. I happen to use cosine these last two times, but in these problems that follow, you'll use sine, cosine, and tangent, and hopefully this SOHCAHTOA acronym is one that you will refer to a lot and help you think through which, if you're going to use sine, cosine, or tangent. All right, awesome work.